Okay, students, listen. This fourth question. Fourth question, what they asked, we have to identify that secondary alkyl halide among the following. Secondary alkyl halide. Let's see that the first one. Fourth question. First option, let's see. 2-bromo 3-methyl butane. 2-bromo 3-methyl butane. Butane means 4 carbon atoms. Just a rough skeleton structures only I am drawing. 4 carbon atoms. Okay, at that 1, 2, 3, 4. At the third carbon, one methyl group is present, CH3, and second carbon having bromine is present. See, among that, if you identify that bromine, halogen is present at second carbon, this carbon is connected by the 2 carbon atoms. That's why it is called a secondary carbon. The secondary carbon halogen is present, that's why it is a secondary alkyl halide. Secondary alkyl halide. Okay, so the answer is first one. Let's see the third and second, third, fourth. Let's see the second option what they gave. 1-bromo 3-methyl butane. 1, 2, 3, 4. At first carbon bromine is present. 1-bromo 3-methyl butane. See, this is that primary carbon only. One carbon is attached to another one carbon, it is called primary carbon. One carbon is attached to 2 carbon, secondary carbon. One carbon is attached to 3 carbon atoms, it is tertiary carbon. Okay, halogen is attached to the primary carbon, it is called primary alkyl halides. Halogen is attached to the secondary carbon, it is called secondary alkyl halide. It is primary alkyl halide. So just a classification of alkyl halides that we already discussed. So according to that, this class answer will get. See, 2-bromo 2-methyl butane. 1, 2, 3, and 4. 2-bromo 2-methyl butane. This is tertiary carbon. That's why it is tertiary alkyl halide. Tertiary alkyl halide. Okay, now fourth one is 1-bromo 2-methyl butane. 1-bromo 2-methyl butane means the bromine is attached to primary carbon only. So that's why it is primary alkyl halide. Primary alkyl halide. So the answer is first option is correct. This first option is secondary. This is primary. This is tertiary, and this is primary. Okay, students. Let's see that fifth question. They gave one reaction. This reaction name we have to identify. What is that reaction name? Already this is very important for board examination and objective also. What is that reaction? Finkelstein reaction. See, alkyl chlorides Rx, that X is equals to chlorine or bromine. Chlorine or bromine, they reacts with sodium iodide. In the presence of acetone, acetone is a solvent. Then the product is RI, alkyl iodide plus NaX. That X is equal to sodium chloride or sodium bromide. So this reaction is, what is the mechanism is going on? This is nucleophilic substitution reaction and halogen exchange reactions. Halogen exchange reaction. Okay, halogen exchange reactions, and this reaction is known as Finkelstein reaction. Finkelstein reaction. Okay, students. Finkelstein reaction. Okay, see, so the answer is a Finkelstein reaction. Now one more reaction is there, that is halogen exchange reaction. This Rx, that X is equals to chlorine or bromine, reacts with silver fluoride or metal fluorides, AgF or SbF3, like metal fluorides. Metal fluorides. The product is what? What is the product will forms? RF. Alkyl fluorides are the product. Is known as Schwarz reaction. Okay. So these two are very very important. Now let's see that what is Wurtz reaction? Alkyl halides. 2 moles of alkyl halides reacts with sodium metal. In the presence of dry ether forms R and R. That is Wurtz reaction. Now what is Fittig reaction? Fittig reaction means aryl halides. 2 moles of aryl halides reacts with in the presence of sodium metal. The byproduct is biphenyl byproduct. Sorry, the product is biphenyl. This is known as Fittig reaction. Okay, students, Fittig reaction. Now Franklin reaction. What is Franklin reaction? Alkyl halides. 2 moles of alkyl halides reacts with zinc metal, Zn. Then the product is RR plus ZnX2. This is known as Franklin reaction. Franklin reaction. So these all named reactions are very very important. Directly the questions will comes from named reactions for JEE and NEET examination. Okay. Let's see that sixth question directly already Darjan's reaction. Sixth question is Darjan's reaction. Darjan's reaction. Okay, students. Now the reactant is alcohol, ethyl alcohol, CH3CH2OH. Ethyl alcohol reacts with thionyl chloride, S double bond O, Cl and Cl, thionyl chloride. Okay, in the presence of pyridine, what are the products? The products are CH3, CH2, Cl plus SO2 plus HCl. This sulfur dioxide gas and hydrochloric acid gas will form. So the answer is C2H5Cl plus SO2HCl. Second option is correct. X, Y and Z products. Okay, students, here the one more important thing is, okay, with alkyl chlorides only why it is possible? Why not alkyl bromides and alkyl iodides? So SO, S double bond O, Br. This is unstable. That's why in this method alkyl bromides are not possible. Alkyl bromides are not possible. And S double bond O and iodine. Iodine size is very much high, large size. That's around the sulfur to iodine atoms does not exist. Means this does not exist. Exist. So that's why alkyl iodides also we cannot prepare. Alkyl iodides also we cannot prepare in this method. So in Darjan's process, only alkyl chlorides only we can prepare. Alkyl chlorides only we can prepare. It is not possible for the preparation of alkyl bromides and alkyl iodides. Okay, students, this is very very important. So in these questions also, why the alkyl bromides and alkyl iodides are not possible, they will ask. So in that case, what we have to write? So what is the reason? SOBr2, thionyl bromide, is unstable. Thionyl iodide, SOCl2 means thionyl chloride. SOI2 means thionyl iodide does not exist. That is the answer. Okay, students. Let's go for seventh question. Seventh question, let's see. 2-methyl butane on reacts in the presence of sunlight. What is the major product? See, the halogenation of alkanes is free radical substitution reaction. See, halogenation of alkanes is free radical substitution reaction. Okay, students, see here the intermediates. What are the intermediate will forms? Free radical intermediate will forms. Free radical intermediate will forms. Free radical intermediates will forms. Okay, so due to the presence of free radical intermediates, the stability, what is the stability order? Stability order of intermediates, free radical intermediates, tertiary free radical. Okay, students, tertiary is more than secondary and then primary and then methyl free radical. Okay, this is the stability order of free radicals. So among that stability free tertiary free radical is present in that alkane, tertiary carbon is present, there bromine will be substituted at that tertiary hydrogen will be replaced by the bromine atom, then the resultant product is the major product when compared to secondary and primary. Okay, 2-methyl butane, CH3 bond CH2 bond CH bond CH3 bond CH3, 2-methyl butane. So 2-methyl butane on halogenation. See what are the different types of alkanes are present. This and this. Both are A, means they will give one type of product A. And the next one is 2-methyl butane is nothing but what, my dear students? Already yesterday only we discussed it. What it is? Isopentane is nothing but it is B. And it is C and D. So how many products? 1, 2, 3, 4 types of mono-brominated products will form. Among that B is, this is a tertiary carbon. Tertiary carbon, that's why tertiary free radicals. Radical is more stable. So that's why B product is major. So therefore B product at halogenation takes place at B carbon. B carbon product is a major product. So what is the product? Let's see. CH3 bond CH2 bond C bond Br bond CH3 bond CH3. So what is the name of this compound, dear students? 1, 2, 3, 4. 2-bromo, 2-methyl. According to alphabets, bromine will comes first. That's why its name is 2-bromo, 2-methyl butane is the major product. Butane is the major product. 2-bromo, 2-methyl butane. Third one is a correct answer. Okay. Next, Hunts-Dicker reaction. Already we are discussed the 8th one, Hunts-Dicker reaction. So once you observe that Hunts-Dicker reaction, what type of product and reactant, what is the difference in their product and reactant? Hunts-Dicker reaction is nothing but silver salts of carboxylic acids. RCOAG, silver salts of carboxylic acids, reacts with either bromine or chlorine, forms RBr in the presence of carbon tetrachloride, alkyl bromide plus CO2 plus AgBr. For example, this silver salts of carboxylic acid has n carbon atoms are present. Let you maybe the product has n-1 carbons. Okay, for example, CH3 COOAG, silver salts of acetic acid treated with bromine in the presence of carbon tetrachloride. The product is bromomethane plus CO2 plus AgBr. So the major product is methyl bromide. Here the reactant has 2 carbons, the product is only 1 carbon. So 1 carbon is less. The number of carbon atoms in Sunstick reaction, the number of carbon atoms, what happens? Decreased. How many carbon atoms are decreasing? 1 carbon atom is decreasing. Okay. So the answer is first one. Carboxylic acids converted into silver salts of carboxylic acids converted into alkyl bromides or alkyl chlorides. In that product contains 1 carbon is less. So the number of carbon atoms decreased. Okay, students, let's go for next questions. Okay, let's see ninth question. Ninth question is just like a Darjan's reaction. Application, instead of alkyl alcohols, cyclohexanol they give. This is cyclohexanol reacts with SO2 Cl2, then the product is cyclochloro. Okay, 1 chlorocyclohexane, SO2 plus HCl. So the answer is third option. What is this name of this compound? 1 chlorocyclohexane. 1 chlorocyclohexane is the product. Let's see the 10th question. Among the following compounds, the highest density. Okay, density is increases with increasing molecular weight. Molecular weight or molecular mass. So if you observe that among that which has more molecular weight is present iodine C3H7I. Iodine molecular weight, gram atomic weight is 127 and carbon 3 carbon atoms are present. Here 3 chlorine atoms are present. Chlorine atomic weight is 35.5 only. Just you have to calculate among that N-propyl iodide has more molecular weight, then N-propyl iodide has a more N-propyl iodide has a more density. N-propyl iodide has a more density will comes. Okay, students. So the answer is a third one. Okay, let's go for next question. Among the following, 11th question. See, AgOH. What is the product they are asked? Ethyl chloride treated with AgOH. Then the product is 11th question. CH3 bond CH2 bond Cl treated with AgOH or moistured silver oxide. Moist silver oxide is converted into AgOH. Then that AgOH, in that OH minus ion is the nucleophile. So here the nucleophile is OH minus ion. So the product is, what is the product? A is CH3, CH2, OH. Ethyl alcohol. A is ethyl alcohol. That ethyl alcohol reacts with ethyl alcohol react with acetyl chloride and the resultant product is ester. C, ethyl alcohol CH3, CH2, OH. This is plus Cl, C double bond O, CH3. Acetyl chloride, loss of HCl means it is a nucleophilic substitution reaction and esterification reaction, my dear students. Then the product is CH3, C double bond O bond CH2, CH3. Ethyl ethanoate is the product. What is that compound name? Ester. Among the following, which is ester? So first and second options are esters only, but ethyl acetate, its common name is ethyl acetate. IUPAC name is ethyl acetate. Our IUPAC name is ethyl ethanoate. Ethyl ethanoate. Ethyl ethanoate. So the answer is what is C they asked. So ethyl acetate. First option is correct. Now let's see that 12th question. The 12th question what they asked. It's very easy, dear students. Now in that KCN is present. The cyanides are the product. Nucleophilic substance. AgCN is present. Isocyanides are the products. Okay. C2H5Cl is treated with potassium cyanide KCN. The product is C2H5CN. Cyanide. The cyanides on hydrolysis in acidic medium, the CN group is converted into complete hydrolysis is converted into carboxylic acids. Now that CH3 bond CH2 bond COOH. Now let's see here in that hydrolysis of cyanides, how many carbon atoms are present? 3 carbons. The product is also 3 carbons are present. This the nitrogen will comes outside in the form of NH3. Okay, students. So the cyanides on hydrolysis, complete hydrolysis, the product is carboxylic acids. For example, in the same way is treated with AgCN, silver cyanide, to produce ethyl isocyanide. CH3 bond CH2 bond NC, ethyl isocyanide. This ethyl isocyanides on hydrolysis, on complete hydrolysis in acidic medium, then it is converted into CH3, CH2, NH2, primary amines. So once you observe that the remaining additional carbon is converted into CO2 plus H2O will come. This here the product is how many carbon atoms are present, dear students? Here 1, 2 and this cyanides, 3 carbon atoms are present. Reactant. Now product has how many carbon atoms are present? 2 carbon atoms are present. So another carbon will comes outside in the form of CO2. So these two different types of reactions I explained. But in the question, the 12th question, they are asked this conversion only. They asked this conversion only. Okay, what is the product? The product is CH3CH2COOH, propionic acid. What is its name? Common name is propionic acid. Propionic acid. Okay, IUPAC name is ANOIC acid. Propionic acid. It is common name. This is IUPAC name. 3 carbons containing acid. Okay, students. So cyanides on hydrolysis producing acids. Cyanides, isocyanides on hydrolysis producing primary amines. Let's see that 13th question. Chloroethane reacts with X forms diethyl ether, they said. So this is nothing but Williamson ether synthesis. Williamson ethers synthesis. What is Williamson ether synthesis, dear students? This is nothing but nucleophilic substitution reactions only. Alkyl chlorides. Alkyl chlorides are alkyl bromides. CH3 bond CH2 bond Cl. Reacts with some product. The product is some reactant. The product is CH3 CH2O CH2 CH3 diethyl ether. Diethyl ether. Okay, see this diethyl ether, this ethoxy ion, here it is a positive charge. Now here it is positive charge and ethoxide ion O minus bond CH2 bond CH3. So here Na plus sodium ethoxide. So the answer is O minus and Na plus sodium ethoxide. So third one, this reaction is known as Williamson ether synthesis. Okay. Next question, let's see the 14th question. One chlorobutane, CH3 bond CH2 bond CH2, 3 carbons, now fourth carbon bond Cl. Okay, this 1 chlorobutane treated with alcoholic potash. Alcoholic potash means alcoholic potassium hydroxide. It is elimination reaction. It is a elimination reaction. Okay, students, it is elimination reaction. Loss of HCl, hydrochloric acid. Loss of hydrochloric acid means it is alpha carbon and beta. Beta elimination reaction will take place. Okay, so the beta hydrogen and alpha chlorine will be eliminated to produce alkenes. That is CH3 bond CH2 bond CH double bond CH2. What is this name? But1ene or but1ene or 1-butane. So the answer is first option. Now let's see one more important thing is instead of alcoholic KOH, aqueous KOH you are used. Aqueous KOH means it undergoes SN2 mechanism. Then the product is CH3 bond CH2 bond CH2 bond CH2 bond OH means butanol, butane 1-ol or 1-butanol is the product. Okay, so now in the 14th reaction, the given question is the butane 1 chlorobutane reacts with alcoholic potash, means it is elimination reaction. The product is but1ene. But1ene is the product. Okay, students, let's go for next question. 15th question, among the following, which is the correct reactivity order of nucleophilic substitution reactions? We know very well for SN1 and SN2 reactions, nucleophilic substitution reaction, reactivity order mostly this is allyl chlorides and then propyl chloride and then vinyl chloride. See, allyl chlorides are more reactive. Allyl chloride. Allyl chloride means what it is? CH2 double bond CH bond CH2X. This is on breaking and produced carbocation is allyl carbocation. Double bond CH bond CH2. This allyl carbocation is stabilized by resonance. That's why it is more reactive. More reactive than alkyl halides. And then vinyl halide. And then vinyl halide. Okay, alkyl halide means what it is? RX. Then it is R plus carbocation. Here vinyl halides, what is vinyl halides, dear students? CH2 double bond CH bond X. Means the halogen is directly attached to the sp2 carbon. It is known as vinyl halide. The vinyl halides, the resultant carbocation is unstable. It is unstable when compared to alkyl. That's why compared to all, allyl chloride is more stable than propyl chloride and then vinyl chloride. So the third answer is correct. Now let's see that the addition of ethanol in aqueous hydrolysis of benzyl chloride does not increases the rate of the hydrolysis. Hydrolysis, it changes only the composition of final product. It indicates that 16th question, let's see the benzyl chloride. Benzyl chloride means it is produce more stable carbocation. It proceeds through SN1 mechanism. The reaction is we are doing hydrolysis in presence of ethyl alcohol. If it is independent on the concentration of it depends on the rate depends on only concentration of benzyl chloride, but not nucleophile, but not the concentration of nucleophile. Hence it is SN1 reaction. Hence it is a SN1 reaction. Okay, if the same way the rate will be changes by the addition of ethyl alcohol, excess of ethyl alcohol on hydrolysis of benzyl chloride, means the rate is changing, means depends on the concentration of the rate is depends on the both the concentration of reactants and nucleophile. Concentration of reactant and nucleophile means it is a SN2 reaction. SN2 reaction is a second order reaction. SN1 reaction is first order reaction. Okay, so here the rate is depends on only the concentration of benzyl chloride only, means the order is equal to 1, hence it is SN1 unimolecular nucleophilic substitution reaction. Okay, let's go for next question. The correct SN2 reactivity order. SN2 reactivity order means what it is, dear students? Primary is more than secondary and then tertiary. So that first option is correct. We know very well that. Next, see here direct iodination of benzene is not possible. Why? Benzene is present. If for example you are doing iodination, iodine in the presence of sunlight, then what happens, dear students? Sorry, not sunlight, in the presence of iron chloride FeCl3 catalyst or AlCl3, then the product is iodobenzene, iodine plus Hi. See here direct again this Hi is strong reducing agent. It is a strong reducing agent. Then it reduces iodobenzene into benzene plus iodine. So to prevention of this reaction, these iodination reactions are carried out in the presence of so this is a forward reaction, backward means reversible reaction. To prevention of this reverse reaction, this iodination reaction is carried out in the presence of oxidizing agents. AlCl3, HiO3, periodic acid or HNO3. Then only it produces iodobenzene. The byproduct Hi again oxidized with HiO3 converted into iodine. Okay, students. So what is the reason? The direct iodination is not possible because of the byproduct produced product Hi is reduced to benzene and Hi. So the second option is correct. Now the toluene. Toluene means CH3. This is on chlorination in the presence of iron chloride FeCl3. Then what is the product? Ortho and para, because the CH3 group is ortho and para directing group. Ortho and para directing group. That's why ortho and para products will form. Among that, para product is major. This is para and this is ortho. It is major product. So they are not asked among that which is major product. What are the products are possible? Ortho and para chlorotoluene is the possible. Okay. Let's go for next question. See this 20th question. It's very easy, ma. Here it is benzylic position. Benzylic carbon. And bromine in the presence of sunlight. It is free radical. Substitution reaction. So instead of this condition also we can use NBS. N-bromosuccinamide. What is that NBS structure, dear students? Bromine. This is N-bromosuccinamide. This N-bromosuccinamide also good allylic and benzylic brominating agent. The product is